Hello everyone. Today we are going to discuss about Bezier surfaces. Concepts which we are going to discuss in today's session are introduction about Bezier surfaces, what are Bezier surfaces, mathematics of Bezier surfaces, applications, advantages and limitations, and finally the conclusion of Bezier surfaces. Introduction. Today we will explore the fascinating world of computer graphics and how it has revolutionized the way we design and create. So, Bezier surfaces are an essential tools in this field, allowing us to represent complex shapes with ease. But what makes them so special? So these are the essential tools in the field of computer graphics, which allow us to represent complex shapes very easily. So what does these make special? Let us know. So what are Bezier surfaces? Bezier surfaces are a type of mathematical model used in computer graphics to represent complex shapes such as curves, surfaces, and volumes. So mainly Bezier surfaces are used to represent the complex shapes such as surfaces, volumes, and curves. They are named after French mathematician Pierre Bezier, who developed them in 1960s while working for the car manufacturer Renault. So these names were given after the mathematician Bezier. At their core, Bezier surfaces are defined by a set of control points that are used to generate a smooth curves or surfaces. These control points can be adjusted to create different shapes and configurations, making Bezier surfaces a powerful tool for designers and animators alike. So, these control points can be adjusted according to the need of the designer or animator to form different shapes and configurations. In computer graphics, Bezier surfaces are often used to create a realistic looking 3D model of objects and environment. So mainly in graphics, these Bezier surfaces are used to create realistic 3D models of objects and environment. These look like realistic things or realistic objects in the environment. Mathematics of Bezier surfaces. Bezier surfaces are a mathematical representation of curved surfaces that are widely used in computer graphics. So these are the mathematical representation of curved surfaces, which are mainly used in computer graphics. They are defined by a set of control points and can be manipulated. So, as we know, we can even manipulate these control points, manipulate or change to create complex shapes with smooth continuous curves. And these are used to make 3D realistic objects in environment. The de Castelgio algorithm is a method for evaluating Bezier curves and surfaces. It involves dividing the curve or a surface into smaller segments and recursively calculating the position of each point. So, firstly, the segment or the curve or a surface is divided into smaller segments and they are calculated separately. The Bernstein polynomials are another important concept in Bezier surfaces as they are used to calculate the position of points along the curve or surfaces. So these polynomials are used to calculate the position of points along the curve or surfaces. Applications of Bezier surfaces. One of the primary application of Bezier surfaces is in computer-aided design, that is CAD, where they are used to represent complex shapes and curves. So through these Bezier surfaces, we can represent the complex shapes and curves For example, Bezier surfaces can be used to model the body of a car or the shape of a shoe sole, allowing designer to create highly detailed and accurate 3D models. So, a main example is that we can use these surfaces to make the model the body of a car or shape of the shoe sole. Additionally, Bezier surfaces are often used in animation to create smooth and realistic movements. So this is the important example or application that Bezier surfaces can be used to create realistic models or 3D models in the environment. By defining a series of Bezier curves and surfaces, animators can create lifelike characters and objects that move and interact with the environment in a natural way. So we can even create the characters like lifelike, and those characters will interact with us in the natural nature. These are nothing but animations which are being created. Another important application of Bezier surfaces is in the field of industrial design, where they are used to create prototypes and models of products before they are manufactured. By using Bezier surfaces to model a product's shape and form, designers can quickly iterate on their designs and make changes as needed. So through these surfaces, we can even change the design as designers need. Finally, Bezier surfaces are also used in medical industry to model and simulate biological structures such as the human heart or brain. So these are used in medical field to figure out the human heart or brain, like human bodies, human parts. This allows doctor and researcher to study these structures in detail and develop new treatments and therapies. Advantages and limitations. One of the key advantage of Bezier surface is their ability to represent complex shapes. By using a series of control points and curves, these surfaces can accurately model a wide range of organic and geometric forms. This makes them an invaluable tool in computer-aided design and animation, where realistic 3D models are essential. However, Bezier surfaces also have some limitations. One of the main challenges is representing sharp edges and corners. So, main challenge is that representing sharp edges and corners, because the surface is defined by a series of smoothly connected curves. It can be difficult to create a sharp corner without introducing unwanted distortion or irregularities. This means that Bezier surfaces may not be the best choice for certain types of objects, such as those with hard edges or angular shapes. So, Bezier surfaces, through these surfaces, we can design surfaces which are smooth, but here making a hard edges or angular shapes is a limitation of this Bezier surfaces. So finally, conclusion. We have explored the fascinating world of Bezier surfaces and their importance in computer graphics. So we have seen how they are defined mathematically using the Castro algorithm and the Bernstein polynomials, and how they can be used to represent complex shapes in various applications such as computer aided design and animation. So we have also discussed some advantages and disadvantages of Bezier surfaces, including their abilities to represent smooth curves and surfaces, but difficulty in representing the sharp edges or the angular corners. As we so these are the limitations, advantages, and the introduction about the Bezier surfaces. So Bezier surfaces are mainly used to create animated or 3D realistic images. Thank you.